Hey there, and welcome to Poppyco Air, where not forgetting the plus C is our #1 priority. Today, we'll explain how we found the initial velocity of a Nerf gun bullet just by using a Nerf gun, a Nerf bullet, of course, a meter stick, a piece of string, some tape, some paper towels, and a plastic water bottle. We measured the mass of the bullet as 0.00102 plus or minus 10 to the negative 5 kilograms. And we measured the mass of the pendulum as 0.02313 plus or minus 10 to the negative 5th kilograms. So that was for the pendulum. We measured the delta H, or the change in height, as 0.029 plus or minus 0.001 meters. And we ended up calculating the initial velocity of the Nerf bullet as 18 meters per second plus or minus
1.4 meters per second.
Now, passing it on to Damian.
This experiment centers on the use of conservation of energy to calculate the initial velocity of a Nerf dart. For the purposes of this experiment, we assume the collision is inelastic and that all kinetic energy is converted to potential energy, ignoring potential energy losses, such as air resistance or sound. Using the equations, potential energy is equal to mass times gravity times height, and kinetic energy is equal to 1/2 times mass times velocity squared, we are able to find the relationship that velocity is equal to the square root of 2 times gravity times height. This is only possible, however, because we ignore other energy losses, such as air resistance, allowing us to say that potential energy is equal to kinetic energy.
Stow all carry-on weights securely and centered in an under-pendulum bin, and place impact-absorbing items inside the pendulum ahead of you. Handheld portable devices, including airspring projectile toys, must also be secured and held steady for projectile takeoff. Please also keep eyes and other obstructions clear of projectile pathway. As you proceed with the lab, if you change projectile launch zone, please do not adjust your projectile and restart your lab from the beginning. As we start the lab, fasten your pendulum by leveling and securing your pendulum to the provided PVC tube stand with string and adjusting your pendulum so it's low and level. Release the projectile by pulling the brightly colored lever back until you hear a click, then squeeze the trigger at will. To capture data, take note of the vertical level at rest and at peak of pendulum motion. Please, be aware of projectile launch zones at all times.
In order to go from measurements to a final answer, we will use a system of equations. Our momentum equation will be for an inelastic collision because the bullet and pendulum move together and maintain constant contact after their initial collision. This equation is m1v1 plus m2v2 equals m1 plus m2 in parentheses v prime. However, we know that v2 is 0. As the pendulum is stationary before a collision, we can cancel out the second term, and solving for v gives us v prime is equal to m1 v1 over m1 plus m2. The other equation is energy, where 1/2 m1 plus m2 v prime squared is equal to m1 plus m2 gh, where the kinetic energy of the system at the moment of impact is equal to the gravitational potential energy of the pendulum at its highest point. We can then plug in our value for v prime into the energy equation. This gives us this equation. Simplify it. Simplify a little more. And finally, we get this equation for the initial velocity of the bullet. v1 is equal to the square root of 2gh, parentheses 1, plus m2 over m1, close parentheses. Plugging in 9.81 meters per second squared for g, 0.029 meters for h, 0.00102 kilograms for m1, and 0.02313 kilograms for m2 gives us a final answer accounting for significant figures of 18 meters per second. To calculate uncertainty, we have two factors. The first factor has a square root, so the uncertainty of that term is 1/2 the relative uncertainty of the terms inside the square root. The uncertainty for the second factor is determined by adding the relative uncertainties of the two quantities. Then the relative uncertainties of the two are added together for a final relative uncertainty. We appreciate you doing your calculations with Pabico Air.
Although we did get a margin of error, there were other factors that we did not account for. We calculated the uncertainty in kind of a weird-ish way. So originally the uncertainty was 0.9%. That's when we calculated using the minimum and maximum. But after we put in the significant figures, the calculated value of the initial velocity went from 17.86 to 18 meters per second. That uncertainty value meant that the calculation was only possible for one edge of the range, which is not right. So after that, we applied a different formula, which gave us the correct uncertainty, which was
7.8%.
And even though both of the ways of calculation were correct, they gave very different values, and they could lead to many different problems in other scenarios and in other labs. One way that we had some error was with the measuring stick. So the measuring stick doesn't go all the way down, potentially. There could be a little bit of a room, a little bit of a gap, and also, our cameras, even though they're as good as they possibly can be, they're not super exact. There was a tiny bit of parallax error, so we have to account for that as well. Additionally, our pennies were not distributed evenly. So we attempted to put our pennies at the very bottom, and then we taped them all together. Some other groups put their pennies in the back or inside their cup, but we decided to tape it to the bottom. So that could have also caused some error. This lab overall taught us exactly how inelastic equations and experiments work. It showed exactly how energy is conserved. And even though we assumed that it's all transferred to potential energy, and we did disregard the fact that there was some energy lost to heat and sound. By eliminating those, we still got a pretty exact value. So it also taught us that even though it's possible to get more and more exact, it doesn't always help out, and sometimes saving time can be more useful and more beneficial. In addition to that, this lab also showcased how if you have values for all other variables in the equation and you just don't have one, you can solve for it pretty easily. You just have to rearrange it, and it's not that bad. Thank you for flying with Pabico Airlines, and remember, don't forget to add the C. Thank you.